All right, so the first thing we're going to do is draw this part 3D in Mastercam. We're going to do some 2D geometry, show you what levels are all about, use the whole function in the solids, and get this part pretty much drawn and ready to roll. We are not going to worry about any of the geometric tolerances for now. We will worry about, the thread specs and we will ream the 3/8 hole here, things like that. But we are going to ignore the datum relations and whatnot for this example. Okay, so take a look at the part. We're going to draw a 2x3 rectangle, 1/2 inch thick. Go on over to Mastercam, and first thing we need to do is name our first level. So we're going to draw a rectangle first, and that rectangle, all right, is going to be 2x3. That's going to be our part outer boundary. So I'm going to name this by double clicking part outer boundary. It is our active level, as this checkbox tells us. So that means that whatever we draw right now will be on level 1. So I'm going to go to the rectangle function in wireframe, and I'm going to anchor to center. That's the way I prefer to draw. And this, because I'm going to move this gnomon later. If you do not have the gnomon there, go to view and go to show gnomons. It'll toggle on and off. All right, so that's all you need. That's just 0, 0. What we need to do is go back to wireframe, go to rectangle, and select the middle and create a rectangle. Now don't double click. This being blue, all right, tells us that you can edit it. So go to width. The width is going to be 3.0, 30, 3.0. And the height's going to be 2.0. Okay, that's done. Hit green check. Now we have 4 entities, 4 lines, 4 separate lines that represent our part outer boundary. You can toggle them on or off. Okay, now it does default to where you can't do that, where active level is always visible. To change that, pull this arrow down, and active level is always visible would be checked. Just uncheck that. Or sometimes I do a blank one, a blank level that has no entities that I could make active, and that way the other ones I can turn off. It doesn't matter as long as you have full control over the levels. It doesn't matter how you do that. Again, that's just right here next to this little yellow gear and the pull down. These would check box. Make sure active level always visible. You turn that on or off, whatever works for you. It doesn't really matter. So now we're ready to make this 3D. So I'm just going to go right click isometric. All right. And I'm going to go to solids. Right. And before I actually make the solid, I am going to do a new level. So hit the little plus sign, and this is going to be part model. And this is the new active level. So anything I create from here on out will be on this level. So go to extrude. The chaining dialog box comes up. There's a lot of tools in here that we'll get into when we get into toolpath, but for right now, it is good practice to always use the default chain, and because if it doesn't work right, you probably have some errors. So hopefully, with this selected, you can click just one of the pieces of geometry on the outer boundary wireframe, and it should loop right around with only one green arrow. Very important. If it does not, if there's a red arrow, you really it should not do that right now. A red and green arrow show you the beginning and end of a piece of toolpath chain, or a piece of chain. You don't want that for this. This is not complex enough to have to worry about that or even get into that yet. So hopefully you have one green arrow, and that tells you that this chain is ready to extrude. You should be good to go. Hit green check. And this is going to extrude down for me. Some tools here, create body. We don't have any 3D bodies yet, so it's going to default to that. Chain 1 is what we just selected. If you right click, you could add a chain, you could rechain all, you can modify it in any way. There are options down here. Okay, reverse all is number 1. Yours is probably going to default to something like this in Z positive. I prefer to always extrude Z negative. If you extrude in Z negative, you are good to go. Okay, I like my 2D geometry in the top. You can work around it, but this is preferred, and this is simple enough that I just change it. You can, if you do hit green check or apply, you can change this later. It's not the end of the world, but just make sure it's Z negative. All right. The distance, make sure you type in 1/2 inch for the thickness of this part. It will default to 1 inch. Once this is all set, you can hit green check. Now we have one part model. It is a 3D solid. All right, so this is where we're going to continue. We're going to work on creating some of these holes. So first hole we're going to work on is the 3/8/16 hole in the upper left corner. So what we're going to do is go to Mastercam. We're going to create a new level. and that level will be called 3/8/16 location. Okay. Now, the location wireframe geometry itself will be on level 3, but the model itself, level 2, will be edited, or will be where the actual 3D hole is. Um, it won't be separate, which is fine for us. Okay. And again, in theory, all you need is a location, but it is good to put the solid hole in there. It also gives us some information on tap drill size and things ahead of time, um, just to show you what the solids is all about. So now that this is there, I know it says it's active. I always right click and make active, okay, out of habit, because sometimes the parent, as far as like we're going to offset this over, the new line will be in the same level as the parent, which is fine. It happens. There's an order of operations here that needs to occur. Um, I've had issues where if all the levels aren't on, either way, the levels won't get put there right during the actual offset, which we'll fix. So I'm hoping that it actually does happen, so I can show you that. Again, levels are just for your organization. All right. So now let's actually offset it. So offset is either in wireframe right here, or it's over in transform and entity right here. So we'll click that. All right. The first distance is we're going to do 531 from the upper line. So 531 is there. Right. Make sure copy is on. Select the upper line and click down. Then hit green check for now to see what happened. Now, luckily, the 3/8/16 location line is on the proper level. If it were not on the proper level, all right, if it is magenta still, that just shows you what's changed. If you right click and clear colors, it'll turn green again. If this was not on the right level, if you left click on it, then right click on it and go to analyze entity properties, down in the bottom here, you could change the levels whenever you want at will. Okay, so it's not the end of the world. So our next step is to get a line in the x-axis direction. Let's take a look there. 938 is our number. So let's go to offset entity, 0.938. Click this line, click over, green check. Okay, it is on the right level. Excellent. Right. There's our location. So now again, we could toggle that on or off to help clean up our drawing. Okay, we could toggle the part boundary on or off. Right. The part model itself. We'll go isometric. Take a look at it. Right click, top view. Now let's actually put the hole in for a 3/8/16. It's going to be a tap drill size. All right, so it should be 5/16. Let's go to solids. Let's go to hole. Okay, this is the whole dialog box. A lot of options in there. The plane orientation is irrelevant. We're just working with the default top plane for now. The position we need to select from the intersection of these two lines. So go to this little crosshairs in the middle and select those two lines. Okay, hole's going to go there. Hit enter. And you'll see the current parameters of a hole occur. So whatever parameters are in there, let's say a 1/4 inch hole. What we need to do is select from the category to tap drills for UNC. Then in the list, find 3/8/16. You'll see now that to the standard in the machinist handbook, the top chamfer is selected. The diameter for tap drill size is selected. We will go through all for this hole. Okay, and that's it. So now we can hit green check. The 3/8/16 hole is now created. Right? And you'll say, well, these lines are going to get in the way. Yes, this is why we have levels. You can turn the levels on or off. Okay. All right, let's show you a different way to create this countersunk hole. Now, you could do all the holes with the offset method. That's fine. I'm just trying to show you different methods to create this and show you different tools using the software on this simple example. So let's take a look at this example here. So what we're going to do is use some of the location tools in Mastercam. So let's get levels, and let's just turn on the visibility of the 3/8/16 location. Okay, so right now we don't need any new levels. Okay, what we do need to do is start messing around with planes, and planes essentially is our 0, 0 for what we're doing. It's going to move the gnomon, which is right here. We're going to put it over in this corner, mainly because basic dimensions are defined from this corner in this example because the 3" and 2" are nominal in the CAD file. So what we're going to do is we're going to go to planes, and planes is also in view. And view planes, and this is the plane dialog box. Here's your default planes. We're using top right now. Top is set as the work coordinate system, the construction plane, and the tool plane. The examples that we're doing, right, typically they're all going to be the same. Work coordinate system is where all of your numbers essentially come from. It is equivalent to tool plane, all right, for most 3-axis operations. The work coordinate system and tool plane will be different if you want some sort of rotary motion. So if you want to do some 4th axis work, if you want to rotate, the work coordinate system would be the center of rotation. Each tool plane would be each rotation axis. Okay, and we may get into that. I'm not sure how that's going to pan out. So for what we're doing to keep it real simple, these 3 will be the same. Construction plane is what you're drawing on, just to be clear. So I can move the construction plane to here, to here, to here, and draw. But a lot of times, I'm just to keep this simple for now and just start messing around with this, just keep them the same for whatever we want to be working with. So we're going to put a new plane here. So we're going to go to Add, Create New Plane. We're going to do Dynamic. I use Dynamic for almost everything here. So go to Dynamic, okay, and you'll see down here you have a little gnomon moving around. Bring the gnomon to the lower corner here and click. Now it's there. That's exactly what we want. We're going to call it lower left hole. And right now, we're going to make it the work coordinate system, or the world coordinate system, the T plane and the C plane. So hit green check. And you'll see in planes, lower left hole is there. Okay, could it cause lower left, whatever. The names just keep you organized. So now that's where we're at. So now what we can do is we can just create the hole. So let's go to solids and go to hole. This is, if we look at the drawing, a 266 through hole. So we'll go down here. This is through hole. We're going to go to simple. We're going to go to countersunk. The diameter is 0.266. The countersunk diameter, let's take a look at what it says, is 510 at 100 degrees. So 0.51 at 100 degrees. All right, I'm going to get rid of the top chamfer. We don't need that. We have a diameter of 266, a countersunk diameter of 510, and a countersunk angle of 100. Double check. Angle of 100, 510, 266 through hole. That is set. So our hole is essentially made. It just doesn't know where to put it. So we want to click the crosshairs again. Okay, click. Now there's nothing to click like we did before. If you hit the space bar, and we're going to type in 438 in the X, so we're going to type in 0.538, comma, 0.563 for the Y, comma 0. So the first one is X, second one is Y, third one is Z. Always put Z as 0. If you want it to be 0, always put X, Y, and Z. So from this gnomon, it's going to put that hole at this location. If we hit enter, now there's the hole location. If we hit enter again, there's the countersunk hole. It is done. Okay, double check and make sure it looks like the model. That's good. We will hit green check. Now you're going to say, well, there's no levels. There's no, how do you edit these holes? Okay, go to solids. Now, if you can't go to solids here, it's in view. This is our solids dialog. You'll see there's our extrusion. If we double click on it, we could edit it. If you double click on the 3/16 hole, you could edit it here. Double click the countersunk hole, you could edit it here. It just pops it back up again. You can change whatever you like. Green check. Whenever you change something like there, it becomes it needs to be regenerated or a dirty operation. This is common in tool paths. It's common in solids. Up on top here, you'll regenerate. Now, make sure as these solids get more in depth, whenever you change something, you regenerate constantly, because if you don't, it becomes issues when saving. Okay, so there's the countersunk hole. Okay, that is complete. All right, so let's take a look at this 3/8 plus or minus 1 hole in the middle. Instead of using the hole function in solids, we're just going to extrude this through extruded cut. So let's take a look at how this works. just for another example, a way to create geometry, give you some options and tools to work with as you build your assignment. So this is right in the middle of the, looks like it's right about in the middle of the workpiece. All right. The 0, 0 for this feature is the upper left. Okay. And what we'll do is we'll move the gnomon again just for practice to that corner. We could go from here, but we'll just move it just for practice and create a new one. And then we will use the spacebar option again and move this over instead of creating lines. We will create this on a new level, and we will actually draw the 3/8 circle. So let's go over to Mastercam, and let's go to levels, and let's do a new level, and we're just going to call this 0.375 hole. All right, right click, make active, just double check to make sure it is active. And what I want to do is I'm going to go to planes, and I'm going to do what I'll do is I'll actually edit this one. Is an option we have. If you right click and edit, you can very carefully select, if you zoom in, very carefully select the center ball, and you can move this to there. And now we'll call it upper left hole. Green check. Okay. All right. Everything looks good. So now we just moved it instead of creating a new one. Right? You can move and edit. All right. A plane, you create a new one. The standard ones are there; they cannot be modified. You could copy it and make a new one, reference that, but it's irrelevant. So you just make one. You make a new one you want to use. So now what we'll do is we'll go to wireframe, and we'll select circle center point. Hit the space bar. So our first is going to be the x, so 1.5. So 1.5. Do not type in x, just 1.5, comma, and it is going to be a negative 1.125 minus 1.125, comma, 0, enter. You see the circle location is now specified. We're going to give it a diameter of 0.375 and hit green check. And go to right click and go to top view. And see, we drew a circle on there. If we go to our levels, you'll see we have one piece of geometry we could turn on or off. Also, the part model, you'll see we have a wireframe. You could draw this all in wireframe. There's no need to use solids necessarily. You will for this example and in this class, but a simple part like this, you can just draw wireframe. So there's a couple options here. I'm just trying to give you the tools you may or may not want to use. So that's there. Okay, so now to put this into the model, as far as, or to edit the model to make it right, we need to go over to solids, go to extrude, chain the circle, hit green check. Now, instead of extrude, we're going to cut body through all and hit green check. There is the 3/8 hole. We could turn off that level and turn off this level if you want. So the only level visible is part model, and there's your part model. Okay, so now we're going to work on the counterbore hole in the upper right. We're going to do offset trim on this. So what I mean is I'm going to offset some lines. I'm going to put the holes, two holes at the center of that line. I'm going to delete these other lines to show you that method. We could use the method we did here, or here, or here. This is sort of, these two are similar as far as the one we just did and here, except for now I want to extrude, we're going to extrude down a 1/4 of an inch. Again, this is just a whole combination of things you can do. Any one of these, you could do this entire part with this method, with this method. I'm just trying to give you a lot of tools you can mess with, so that as we continue and the parts get more complicated, you have a lot more in your arsenal to work with. So let's worry about over here. We're going to go to right click and top view, and we're going to turn on part outer boundary. We'll create a new level for this. The new level is going to be C-bore. Okay. And right click, make active. I always do that. I know I don't have to, but I just have it. What we're going to do is we're going to offset some lines. So we're going to go to wireframe and offset. And we'll double check here. And it looks like it's going to be a 1/2 inch and 781 thousandths. So we'll go 0.5 from here. We can break this up now. We can hit apply or OK and create. It's sort of like apply. The window here will not go away. If you hit apply, now this line is created. we can then type in, let me double check my numbers, 781.781 from the top line down. Now hit green check, and both are created. The issue is now, notice both these pieces of geometry went on part outer boundary. Problem. Okay, so let's right click clear colors to turn everything green, and let's put these two lines on the counterbore level. So let's right click, or left click, I'm sorry, right click, analyze entity properties, put it on level C-bore. You'll see that turn to 1. Click this line, left click, right click, analyze entity properties, put it on level C-bore. Now they're on there, so now they turn off separately from part outer boundaries. You could change that at any time. Now, we need to create a couple arcs centered on here. So let's use some different tools here. We could just put at the intersection, but I want to show you some tools. You could actually left click on this and just hit delete in the keyboard. The whole line will go away. But what I want to show you is, see how these are two lines? Let's say I wanted control and I wanted to break this. If you go to break at intersection, select these two lines and hit enter. Now there are 4 lines. So now you can click and delete on the keyboard anything you want. Another example, let's say I didn't want to delete that, you could always go to undo. Now if you don't want to break it, okay, you don't have to, you're just deleting lines, you could always go to divide, and divide will essentially just go like that. Okay, and you don't have to break anything. Just an example of break at intersection and divide. Now I recommend that you break at intersection often, depending on what kind of control you want. As we get into more advanced examples, you will see me do that. It is extremely helpful. It breaks the entities up into more finer elements. So instead of, otherwise it's very difficult to chain that. If you need to go here to here, you can't do that unless you break them. So anyway, I just deleted those just to give us a good endpoint. So what we're going to do is we're going to take a look at our drawing, and we're going to create a 397 thousandths diameter hole. So go back to circle center point right here, type in a diameter 0.397, enter. Okay, we'll hit green check. Now we'll create the counterbore diameter, right, which is 719. So let's go back to circle, click here in the middle, and type in 0.719, enter. Okay, there they are, green check. Now there's no reason to keep these two lines, so you can click and delete, click and delete. So now we should only have the counterbore 2 pieces of geometry. That is the offset trim method, where you offset geometry what you need and trim what you don't want. All right. Now, if we wanted to move these circles now, you could right click, analyze property, click here again, and then you can go and you can move these based, and they are based right now in this current gnomon up UL hole. But you could change diameter here, whatever. So you can change it anytime you change a level, things like that. So what I want to do now is I want to go to solids and extrude. I'm going to select just the middle hole and hit enter. The middle hole is going to be through all, cut, green check. Take a look, it's good. We're going to extrude again, select the outer boundary, hit green check. Now this is not through all. We're going to look at our drawing. This is 1/4 inch deep. So we're going to go distance 0.25 and make sure it previews properly, which it does. Then hit green check. Okay. Now you see the 2D geometry is still there. We can turn off the counterbore and our model looks good. Okay. And again, go double check your solids. You'll see the extruded cut there, the extruded cut there, this extruded cut, the countersink hole, the tapped hole, and then the extrusion. You can edit any of those. Okay. All right, so this final hole, the 7/16 14 class 2 thread, what we're going to do is we are going to move our gnomon over to the lower right corner, and then the gnomon, we are going to use some of the tools to move at specific distances, in this case 3/8 in the y and 5/8 in negative in the x. We're going to actually put the gnomon on the center of the hole to show you how to move the gnomon, some other things, and then we'll create this tapped hole, all right, as we would the upper one over here. Let's go back to Mastercam. Okay, and let's go to planes. What I want to do is right click and edit this gnomon. Click the center ball. Make sure you're right on that. Otherwise, you can pick other options to rotate it and move it one axis at a time. So make sure you click the center one and move it over to here. Now, we want to click the X, and you see you get a little ruler. It helps you gauge, but I'm just going to type in minus 0.625, enter, enter. I'm going to select the Y axis and type in 0.375, enter, enter. Now I'm going to double check my drawing, 3/8, 5/8. The gnomon is now where I want it. We're going to do this moved, or we can just label the thread size. So we'll just do 7/16, 7/16 a hole. Just something like that quick. Green check. So that's our 0, 0 is the center of that hole. All right. So now we have some options. If we go to hole, okay, we can actually go through and I'll actually create the hole first. I'll go into the template. I'll go into the tap drills for UNC, and we'll go in and select 7/16, 14. And the tap drill size is 368. It is a through all hole. I will then select the auto cursor add position. Okay. And you can come over very easily and highlight to the center. Make sure when you do this, you get the little green cross there. Hit enter. Now we have position 1 on the gnomon. There was no reason to hit the space bar. We could have hit the space bar and went 0, 0, 0. It's equivalent. Okay. We can now just double check everything. We're good to go and hit green check. Now the hole is there. We'll check out our planes and see what we have. Now notice this counterbore has an extra piece of geometry. It has the point reference on here. Okay. All right. So let's take a look here what we got. I'm going to turn the part model off. All right, I'm going to turn counterbore on. See the point right there? See that point? If I window that point, right click, be very careful with this. Select, right click, analyze entity properties. This is the point that was created in the create hole options in solids. You would have noticed that up here, the 3/8/16 location gained an entity because of that point. If we go to level, okay, we can put that anywhere we want. Okay, what we want to do, all right, is select level 6 and name it 7/16 hole. Let's hit green check. So now we got to create a new level in a different way. We create a piece of geometry in a different way. We can hit green check. And we can turn essentially everything off except for the part model. And now the part model is complete. Right? We will take one more step further, and we are going to create a stock geometry. Okay, so now the last thing I want to do is create some stock geometry to reference my stock for stock creation later on. So for this part, the material is already 2 inches wide, so we're not going to worry about that. I know there is a profile of a surface tolerance on that probably would not be hit by regular stock material, but we're going to assume that it has been milled or it's already achieved in some way. The ½ inch has an STK on it, which means ½ inch stock is fine. Again, we are ignoring the geometric tolerances for this to an extent just to get through some of these simple examples. So the only one we're really worried about is going to be the 3-inch. So we're going to cut that in the saw at 3 1/8. So we'll go back over to Mastercam, and I'm going to add a level 7, and stock. Okay, it is visible. I am going to turn the part model. You can double check and turn that on or off. We don't care about that. One thing also, notice I am on the top plane. We left off, you were on this plane. If we turn the part model on, you can see, there we are. We want to make sure we're back on top. And top is going to be, all right, a matter of clicking in this little spreadsheet, work coordinate system, construction, and tool plane on right there. Okay, so Now we're ready to draw our geometry. What I'm going to do is go back to levels and turn visible off, turn planes back on for now. We could go to levels. I will double check and make sure stock is active. I will then create a rectangle, anchor to center, click the gnomon in the middle, make sure that little green crosshairs comes up. Come out and create this at a width of 3.125 and a height of 2 inches, which is our stock. And the reason for doing it this way is that since we anchored the center on the top plane on both the stock creation and the part creation, that the 16th of an inch on each side will be evenly distributed on each side without us messing around too much. So now we can hit green check, and we can double check that that stock is there. Okay. What I will also do is I'm going to create a stock model just for an example. So what we'll do is we will actually I will create the stock. Uh, it depends on what you want to do. If you want to do it on a different level or not. Um, let's just create the model for now, and we can move it around. So let's go to solids, extrude the rectangle again, just like we did with the part file, and it's going to be 1/2 inch, 0.5 away, z negative, green check. All right, now notice the stock, everything on the stock is on one level. You can left click, right click, analyze entity properties on the solid and change the level if you like. You don't have to, but right now, just X out of there. I'm going to leave it the same. One thing we could do is change the color of the stock versus the part. It's irrelevant for now. It's up to you if you want to click on it, right click, analyze entity properties, go to colors, and we can make it red is sort of default for stock and Mastercam, so green check, green check. Now there's that, and then the part model, you'll see it's in there, sort of gray. You can turn this on or off. Okay, so there's our stock, there's our part. And that's sort of one of the reasons for separating these is because it's just tough to see. So we'll do that now just to show you. I'll turn the part model off. I will create a new level, and this would be stock model. And I can right click or left click, right click, and analyze entity properties, and I can change the model to stock model, level 8, green check, green check. So now I can turn the 3D off and leave the 2D on. The benefit of this is I can go to top view, turn the model on, and make sure that my stock is on the outside very easily. Okay. So I am definitely going to save now. I would have saved every single pause in this video, uh, but this simple model doesn't, whatever. Save often with Mastercam, especially at home, not knowing the exact computer you're running. But file organization is key. Now that we're done, I'm going to just go File, Save As. And what I'm going to do is I'm just going to go to my desktop, my computer, and I'm going to right click, new folder, and I'm just going to name it mod 1. Okay, I'll double click that folder, and this is going to be part. Okay, or part number, or you could look at the, yeah, again, you could look at the drawing and name it. I don't really, it doesn't really matter to me. Okay, this could be block drill HO18P1. It doesn't matter as long as you can find it later, because we're going to be bringing this in or out, and it's going to matter later on. So we'll just name a part and hit save. Okay, now you can upload it anytime it has some sort of meaning. File management is going to be key. Okay, so this part is complete. Hopefully that helped you with different methods of geometry creation. When you do your example file, you don't have to do it this exact way. You could use any bits and pieces of this as you want, but you are going to be required to have the stock model, the stock, all the holes done, the part model correct, and the part outer boundary there. So some of this stuff you have to do, but again, these holes were all created using different methods. Uh, what method depends on the application. It depends on how you like to draw geometry. It is not strict. I just wanted to give you a little insight on all the different tools that were at your disposal.